Okay, so this is a continuation of the lesson 4-3 notes. This is where we began the notes on Monday, November 26th, 2018. This is the material that will be on the quiz on Friday, November 30th, 2018. So, we are talking about factoring by grouping. Factoring by grouping is a method we use when we are factoring polynomials with more than 3 terms. And we also use it to factor our trinomials if a is not equal to 1. So the way that this process works is based on the greatest common factor that we have already worked on. The reason it is called factoring by grouping is because we take our 4-term polynomial and we group the first 2 terms and the second 2 terms. Now notice that I group the negative with the 3. This is important that you always remember that if this third term is negative, the negative has to be grouped with that third term. Now what we do is we go to the first set of parentheses and we say, what is the greatest common factor of these 2 terms? These 2 terms have a greatest common factor of 2x. So we go ahead and we factor 2x out of that set of parentheses. Now remember, the end result of that is each of these terms will be divided by 2x. So that would give me 2x times the quantity x plus 3. Now the goal of grouping is to make sure that this parenthesis matches what we end up with here when we factor out the greatest common factor. So the greatest common factor of these 2 terms is 3. However, to make the signs match, we actually need to factor out a negative 3. And that's probably the most complicated part of factoring by grouping, is we have to make sure that this binomial is the same for both of these after we take out the greatest common factor. Now the reason we did this is because now our 4-term polynomial has become a 2-term polynomial. Since a term is when we multiply expressions together, these 3 items, 2x and x plus 3, are all being multiplied. So this is 1 term. So this is now a binomial because I have a term here and a term here. And not only is it a binomial, but it is a binomial that has a greatest common factor of x plus 3. So in essence, what we're doing is factoring this x plus 3 out, which would leave 2x minus 3. And that is how we factor by grouping. So let's look at some more examples of this. Now these examples all involve more than one variable, which is rare, honestly, in Algebra 2, but it does help us practice the skill. So we go in and we group the first 2 terms, group the second 2 terms. We take out the greatest common factor from the first set of parentheses, which would be y, and that would leave behind 4x plus 3. Then we look at the second set of parentheses. The greatest common factor there would be 5, so we factor out a 5, and we should notice that that would also leave behind 4x plus 3. It is extremely important that these binomials are exactly the same. So when we factor out 4x plus 3, we are left with y plus 5. And that is the factored answer. On the next problem, we would group again the first 2 and the second 2. Here we have a greatest common factor of n. When we factor that out, we're left with p plus 2. Here we have a greatest common factor of 8. So we would factor that out and again end up with p plus 2. It's extremely important that these are the same binomial. So then we're going to factor that binomial out, p plus 2, which would leave behind n plus 8, which is the factored form of that polynomial. On to letter C. Again, we group, factor out the greatest common factor. For the first set of parentheses, they have an x in common, so I factor out an x. For the second set of parentheses, both of these terms are divisible by 9, so I factor out a 9. Once again, notice these 2 binomials are the same. That binomial is one of our factors, And what's sitting in front of those binomials is the other factor. So y minus 7, x plus 7. Finally, on letter D, we group. Remember to group the negative with the 10. Means there's a new plus sign in between, but it's not going to stay there very long. We factor out the greatest common factor from these two terms. The only thing they have in common is a b, so that leaves 3c minus 2. Here they share a 5 in common. Now we need to be careful here, because we are going to take out positive 5. That would leave negative 2 plus 3c. It is very important to note that this is exactly the same as 3c minus 2. This is because of the commutative property of addition, which says that a plus b is the same as b plus a, which would be 3c plus negative 2, or 3c minus 2. So notice that these are actually the same binomial, and we don't have a problem. Now when we factor this binomial out, we can write either form of it. However, mathematical notation says we should write it in descending order, so we should use 3c minus 2. It is not incorrect to write it as negative 2 plus 3c, but it's more correct, more acceptable, more standard to write the 3c minus 2. So then what's left over would be our second binomial, which would be b plus 5. Moving on. Same deal. These are just more practice. We're going to group. Factor out the greatest common factor. So from here we would take out a c. Note that when we take away everything, there's still a 1. So that would be 1 minus 2d. Now if we notice, when we go to do the other side here, if we take out 4, we would be left with 2d minus 1. Now unlike addition, subtraction is not commutative. So 2d minus 1 would not be the same as 1 minus 2d. So instead we need to take out negative 4, which would give us negative 2d plus 1, which is the same binomial as 1 minus 2d. So these are the same now. So we factor that out. Again, we're going to use the version that has it written in descending order, which would be negative 2d plus 1. But if you used 1 minus 2d, it wouldn't really matter. It would still be the same thing. Our other binomial would be c minus 4. Again, if you're ever unsure about your answer, you can always multiply this back out using the FOIL method or the box method, and the end result should be what you started with. Moving on to letter F, we group. Remember to group the negative with the 7. Factor out the greatest common factor. That would be 9f, which would leave g minus 5. Here we would need to factor out negative 7 to also get g minus 5. Factor out the g minus 5 next, which would leave 9f minus 7. On to the next one. We're going to group the first two, group the second two. Again, that negative needs to be grouped with the 4. From the first set of parentheses, we can take an x squared, which would leave x plus 4, which means to make the signs match, we're going to need to factor out a negative 4, which would leave x plus 4. Factoring again, we pull the x plus 4 out, which would leave x squared minus 4. Now, this happens occasionally in Algebra 2 as well. This problem is not completely factored yet. Although x plus 4 is done being factored, x squared minus 4 fits one of the earlier molds we discussed in class. It is a difference, because that's a subtraction symbol, of two perfect squares. So it can be factored again, which means we're going to leave x plus 4 alone, but x squared minus 4 will factor again. The first term in each of these new binomials will be the square root of x squared, which would be x. There will be one plus and one minus, as that is the pattern we follow for difference of two squares. And the second term will be the square root of 4, which is 2. This would be the fully factored expression. Finally, on letter H, we group. take out the greatest common factor, which would be x squared, leaving 3x plus 2 for the first one. Since we need that to be a plus and it's currently a minus, we need to take out a negative 5, which would be 3x plus 2. That means our two binomial factors are 3x plus 2 and x squared minus 5. Now you may be thinking to yourself, hey, I might need to factor this again. However, x squared minus 5 is not a difference of two perfect squares. It is a difference, and x squared is a perfect square, but 5 is not. So this binomial does not factor again, and we're done with that problem. Grouping is also the method we use to factor trinomials when a does not equal 1. Okay? So we'll have some number in front of x squared. Now this is still somewhat similar to the method we used earlier in class to factor trinomials where a is equal to 1, but there are also some differences. Now before, we would look for factors of c, this third number, that add to b. However, we could only get away with that because there was no number here in front of x squared. Instead, what we need to look at is the number a times c. So we do 3 times 4, which is 12. And we need to look at the factor pairs of 12. Now remember that that could be positive or negative numbers as long as they multiply to negative 12. So there are a total of 6 pairs of numbers that multiply to equal 12. We want the set that adds to b. We need the set that adds to 7 in this case. See the 7? So that would be 3 and 4. Now before, those would have been our numbers that went straight into our factors, and we would have pretty much been done at this point. But it's not that simple when a is not equal to 1. Instead, what we do is we're going to take this middle term and we're going to break it into two separate terms, which would change us from a trinomial with 3 terms into a polynomial with 4 terms. Notice I broke it into a 3x and a 4x, which were the numbers we identified here. It does not matter if we write 3x or 4x, or if we start with 4x and then do 3x. When we factor by grouping, we should get the same answer either way. So, like I said, we're going to factor this by grouping. So then we're going to group the first two and group the second two and factor out the greatest common factor. So for the first set of parentheses, the greatest common factor would be 3x. That would leave x plus 1. Second set, I would factor out a 4, which would leave x plus 1. Just like before, we're going to factor that x plus 1 out. That's one of our factors. And the other factor will be made up of the stuff that's left in front, 3x plus 4. So there is the factored form of our trinomial. We're going to do the exact same thing here. We're going to do a times c, which would be negative 18. Then we look at the numbers that multiply to equal negative 18. That's a 9, not a 6. There we go. So again, there are 6 possibilities. We want the set that adds to our b value, which is positive 3. See? 3, right there. That would be negative 6 and positive 3. Those are the ones that add to 3. So again, we're going to break this up. Now, I have a suggestion for you. Anytime that you're breaking up a term and you have one positive and one negative number, try to write the negative number first. This will greatly reduce the chances that you mess up your factoring by grouping. So we're going to go in and we're going to group. First 2, group the second 2. And we say to ourselves, what do I take out of this first set of parentheses? Well, that would be an x, and leave 2x minus 3. 6x minus 9, I would factor out a 3, which would leave 2x minus 3. Again, the goal is to make sure these binomials are the same, because that is what we factor out next. 2x minus 3, and that leaves what's left in front of the parentheses, x plus 3. We're going to keep looking at examples here. Okay, so again, these are just two more of the same thing. So we do 5 times 6, a times c is 30. So we look at our factor pairs of 30, and I think there's a total of 8 of them this time, counting positive and negative. Again, it's positive 30 because 5 times positive 6 is positive 30. So we want the set that adds to 13. That would be 10 and 3. And again, if you can do it without the list, that's wonderful. Do it without the list. But the list is a very safe approach. And we're going to break that 13x up into a 10x and a 3x. And again, it doesn't matter which term you write first, as long as they're both there. That's the 13x is getting broken up into those two. Then we're going to group. So 5x squared and 10x get grouped. 3x and 6 get grouped. And we're going to factor out the greatest common factor. So 5x comes out of the first set of parentheses, leaving x plus 2. And 3 comes out of the second set of parentheses, which leaves x plus 2. Then we factor out x plus 2, which leaves 5x plus 3. Now there are alternative methods for factoring these polynomials. If you have another way of doing it that you like that works every single time, I don't have a problem with you using that in class. Alright, continuing. A times c is 30 again on this problem. So we already know what our factor pairs are, we just have to find the right one. It's the same list as the previous problem. 3 and 10, negative 3 and negative 10, 5 and 6, negative 5 and negative 6. This time we want the set that adds to 17. Well, that would be 2 and 15. So we break it up, 3x squared plus 15x plus 2x plus 10. Again, we're breaking that 17 up into two other things. Group. Factor out the greatest common factor. So from here I can take out a 3x, which would leave x plus 5. And from here I can take out a 2, which would leave x plus 5. Factor out the x plus 5's, which would leave 3x plus 2, giving us our factored answer. This brings us to using this skill to solve quadratic equations. So here we have a couple of trinomial equations where a does not equal 1. So, same deal, we're kind of going to ignore this equals 0 until this is factored. 2 times negative 5. So a times c is negative 10. That means we're looking at pairs of numbers that multiply to equal negative 10, which means one will be positive and one will be negative. And we want the set that adds to positive 3. That would be negative 2 and positive 5. So again, we want to break that up and we want to write the negative first just to protect ourselves from making silly mistakes. Again, that's 3x is being broken into two terms because 5x minus 2x is still 3x. We have not changed any value. We're going to group the first two and group the second two. Factor out the greatest common factors of each. So that would be a 2x from the first set of parentheses and a 5 from the second set of parentheses. In both cases, we'd be left with x minus 1. We're going to take that x minus 1 out next, which would leave 2x plus 5. Remember, this still equals 0. So we've finished our factoring, but we have not solved the equation yet. Next, we need to apply a rule that we talked about much earlier in this chapter. That is the zero factor theorem, the zero product property. I don't remember which name we used this year. What it says is that we have two things being multiplied together, 1, 2, that equals 0. that means that one of those two things has to equal 0. So hopefully we remember that from earlier in the chapter. This gives us two equations to solve. Now, neither one of those equations should be difficult for us to solve. The first one, we would add 1 to each side of the equation, which would give us the first solution as x equals 1, or on the second one, we would subtract 5 from each side as the first step, which would give us 2x equals negative 5. And then we would divide each side by 2, which would give us x equals negative 5 halves. Now, I don't know if you're working ahead of me or not, but some of my students did during class, and they discovered a problem with this trinomial, but it's not really a problem. It's actually in there for a very specific reason. The first thing I want to point out is that anytime we factor, no matter what kind of factoring we're doing, we should always be looking to see if there is a greatest common factor. And this trinomial, 8x squared minus 6x plus 10, has a greatest common factor of 2. So before we start even looking to see how we factor it, we should divide everything in the entire equation by 2 because we can, and that will make the numbers smaller. So that would turn this equation into 4x squared minus 3x plus 5 equals 0. Now, the graphs of these two things are not necessarily the same graph, but they do have the same solutions. So that means they are mathematically equivalent when it comes to their solutions. So from there, we would go a times c to see what we're looking at. Well, unfortunately, when we do that, and we go through to look to see what numbers multiply to 20 and add to negative 3, we run into a bit of an issue. This is all the numbers that multiply to 20, and not one pair of them adds to negative 3. So this trinomial is what we call prime. Now that means it doesn't factor. That doesn't mean it doesn't solve. So what we should write in this situation, which is going to be exceedingly rare, my guess is you will not see one like this even on your homework assignment, is we would write cannot be solved by factoring. We'll revisit what to do about these kind of equations in a later section when we discuss the method that will work to solve them, the quadratic equation. Now, I can look at this right now and I can say a is 4, b is negative 3, c is 5, which means the discriminant, which we'll talk about later, will be negative. And it does have two solutions, but those two solutions are not real numbers. So this has some real algebra 2 value to it, but we're not going to talk about that today. All right, final slide. We're going to do the same thing. Now keep in mind that anytime we're going to be solving by factoring, we need our equation to equal 0. So if we look, this equation does not equal 0 yet. Our first step has to be to make it equal 0 by subtracting 5 from each side. Now keep in mind that these do not combine. They're all non-like terms. So we simply write 2x squared plus 9x minus 5, and then we have it equal to 0 now. So from there, we're going to ignore the 0, and we're going to factor. 2 times negative 5 is negative 10. So we're looking for factor pairs of negative 10, 1 and negative 10, negative 2 and 5, 2 and negative 5. And we want the set that adds to 9. That would be negative 1 and positive 10. So we break up our center term into a negative 1 and a positive 10. Notice I didn't have to write the 1. You can if you want to. Doesn't make any difference. We group and we factor. So here we can take out an x, which would leave 2x minus 1. And here we can take out a 5, which would leave 2x minus 1. Factor out 2x minus 1 next. And your other factor would be x plus 5. Then, since we still have to solve, we apply the zero product property, which says 2x minus 1 equals 0, or x plus 5 equals 0. and then we will go in and solve these two equations. So this one here, we would add 1 to each side, which would give us 2x equals 1. And then we would divide by 2, which would give us x equals 1/2. On the other equation, we should subtract 5 from each side. It's a one-stepper. And we get x equals -5. So those would be our two solutions for this quadratic equation. Moving on to letter F, same idea. We need it to equal 0. So we start by subtracting 4 from each side, which gives us 5x squared minus 8x minus 4 equals 0. We do a times c, which would be -20. And we look at the factor pairs of -20. There's 6 total pairs. We want the set that adds to -8. That would be 2 plus -10. So we break up that middle term into a -10x and a +2x. Again, we want to write the negative first because it reduces the chances that we're going to make a mistake. So then, and I'm trying to fix that right parenthesis because I don't like it very much. There we go. We group and we factor. So here we can take out a 5x, which would leave x minus 2. And here we can factor out a 2, which would leave x minus 2. We're going to factor out those x minus 2's next, which leaves 5x plus 2 as our other factor. Again, we're going to use the zero product property to break that into two separate equations. Each parenthesis will be set equal to 0. And then we solve. So add 2 to each side here would give us our first solution as x equals 2. Over here we're going to subtract 2 from each side, which would give us 5x equals -2. And then we would divide by 5, which would give us x equals -2/5. Now one last thing, ladies and gentlemen, you'll notice I wrote the fractions 1/2 and -2/5. I did not give the decimal equivalents of 0.5 and -0.4. You are in Algebra 2. You should not be giving your answers as decimals. They're going to be a nightmare for you if you try to do things with decimals later in this course. That's it for factoring by grouping. Hopefully this will help you prepare down the road.